Hey everybody, and welcome back to Jim's Garage. Now, a lot of you on the channel, and when I first started out, might only have a single device. And that's something I want to think about and show you today how I would approach that. Now here I've got the HL15, but you could use any device for this. And the reason I want to cover this topic is several fold. Firstly, most of you may only have one device, that's all you want to have. That could be for space reasons, it might be monetary reasons, it might be the actual operational cost of it, plus also you value your time. You just want to have all your eggs in one basket. You want to try and maximize the return on investment of that single device. So whilst I did mention that I'll be using this HL15, and that does have some advantages which I'll discuss, there's no reason why you couldn't just use something like an old gaming PC, a second-hand system that you've picked up off eBay, or even things like a mini PC like I've covered many times on this channel. Things like the MSA one, for example, that's a good choice. B-Link, you know the usual suspects, those sort of small single-board computers that you can basically have as your home lab. Now the key differentiators between most of those devices is going to be things like the additional peripherals you can actually put in these devices. So for the most part, I'd probably say that the CPU isn't too much of an issue. Most home labbers are only going to need a modest CPU. You're more interested in things like RAM, so how much you can actually run on this machine, as well as things like storage space, but also the potential for peripherals. And that's where something like this device comes in terms of it's more of a workstation. That uses things like Xeon and Threadripper processors, and it also uses that workstation motherboard, which has the benefit of multiple PCIe lanes. Now, typically as you move down that stack, so if you had like an old gaming rig or an old PC, you've probably got about 16 or 20 PCIe lanes to play with, which should be enough for a simple setup. When you get onto the smaller devices, things like those minis forums, those B-Links, etc., that small form factor build, again, you probably have some similar number of lanes to those larger PCs, but the problem is you don't have access to them because of their size. You don't have access to a lot of the PCIe slots. You'll often have to fall back to things like using M.2 slots. So in this video, I'm going to be using this chassis, but it doesn't really matter which one you're using as long as you kind of apply the same thought process. So for this, which is traditionally sold as a NAS, I'm actually going to use it more as the name suggests, the Homelab 15. So I'm going to try and build an all-in-one using this machine. Now whether I actually go through that fully and use it and deploy it, replace my cluster of MSO1s, etc., I'm yet to decide. I am thinking that the power savings, the administrative overheads, etc., it might be worthwhile, but there's definitely some pros and cons to this approach that we need to talk about first. So I think I've already touched on the pros, the fact that you would only need a single device. Basically, whatever form factor you've got, this one device is going to do everything. The problem you've got is this one device does everything. So let's say, for example, I've got my NAS on here, I've got my firewall on here, and I've possibly got some virtual machines, maybe some Dockerized environments, etc. If I need to reboot my firewall, I'm going to have to reboot potentially other things on this device. I'm going to suffer downtime. So that's typically why I've always said to basically abstract the firewall from your home lab. It's a discrete device that you would have somewhere else on your network. Anything goes wrong, you've still got access to the internet, and also probably more importantly, the devices on your network, you can route to them. Similarly with the NAS, for example, I'd probably stick something like TrueNAS on here. That's what I'm used to. I will be checking out the Houston OS as well because I'm really keen to see that in a future video. But I'd probably put TrueNAS on here, and that has the same sort of issue potentially. If I were to reboot my device here, I would lose access to all of my storage. And especially if someone is accessing it at that time, that could be a problem. Again, another reason why traditionally you'd want to isolate or you'd want to put this in a disparate device, your NAS storage. Lastly is probably the compute and whatever you're running, your virtual machines, LXCs, whatever it might be. Obviously, rebooting this, you're going to have to suffer some downtime in whatever services you're running. If you're using things like, I don't know, DNS or Plex, Jellyfin, a whole host of other features, could even be you're running, I don't know, a WireGuard container. You're going to lose all of that when you reboot it. So that's kind of a brief overview of the pros and cons, but I also think there's the cool element to it, whereby centralizing as much as possible into one device, I do think it kind of maximizes your skills. You have to think outside the box, you have to navigate around these problems, and at the end of the day, home labbing is just about having a bit of fun. So in this video, I'm going to be opening this thing up. We're going to have a look through what's potential in here. You can obviously take some of these practices and apply them to other devices. So for common things, I'm probably going to set up on here a OS. I'm going to put probably Proxmox on here as the hypervisor. I'm likely going to install a firewall, probably something like OpenSense or pfSense. I'm going to add a discrete GPU in here because this EM processor doesn't have a GPU. That's going to enable things like transcoding, etc., and hardware acceleration for basically anything graphical. And then I'm probably going to deploy a virtual machine on here just to take advantage of that. I might also put in here as well things like a HBA, because whilst this does come with one, a device that you get off eBay, a secondhand gaming machine, it's not going to have a host bus adapter that you can pass through. So we'll also have a look at doing that. Now when it comes to utilizing those PCIe lanes that I just demonstrated, especially for building an all-in-one, we've got a number of options. And here's some of the things that I have lying around that I would probably want to consider when putting into an all-in-one build. So probably the first thing that you're going to need, especially if you've got a more consumer orientated device, is something like this. This is a host bus adapter, and effectively what this does is it's going to take a ×8 PCI connector and it's going to break it out into 2 SAS connections, each of which I believe on this model I think they can take 8 SATA drives each. So that will allow you to have 16 drives. You can pick these up on eBay pretty cheaply. Some of them do require active cooling, so just check the model on that. But yeah, you should be able to pick these up for say 30-40 quid on eBay, which is pretty much a bargain. Next up, as I mentioned, is the discrete GPU. So this one's nothing too fancy. This is just one of the Intel Arc. This is an A380, I believe. Pretty low powered in terms of actual compute as well as power draw, albeit the idle's slightly higher on here. Probably if you can, especially if you've got a consumer device, you might already have an integrated GPU, which I've covered in recent videos, and pretty much that's going to cover you for most applications. It's probably something just like this Intel Xeon board or maybe a Threadripper or something like that that won't have a discrete GPU. This one does, with a workstation board, have out-of-band support, so this one has IPMI. So I can actually remote into this and get a desktop output, albeit you can't use that really for any kind of compute. So this would be useful for, say, a Docker virtual machine or any kind of virtual machine that you're going to use to accelerate graphical workloads. Next up, we probably want to add some networking. Now, because this is quite handily a workstation board, it actually comes with a couple of 10 gig NICs already on it, which is pretty much the standard if you want to have a decently performing NAS, and especially if you want to start clustering this machine, or at least having multiple virtual machines on here all sharing the same network connection. Now here I've got, and I typically recommend Intel NICs. Here I've got a quad port. This is only 1 gig. It's pretty old, but because it's pretty old, it's pretty cheap as well. You can actually pick this up on eBay for about £30-40 these days, but I do recommend, if you've got the budget, and do bear in mind you will need to have the network hardware as well, so the right switch, you could get something like this. This is a Mellanox Connect X card. This is the 3. It's pretty old now, but it's still supported on most operating systems. And this is 10 gig SFP+, so like I said, make sure that you've got a switch that can support this. Don't just buy this and expect it to go to RJ45, although you can get adapters for it. So this will be really useful for maybe building out a firewall. So for example, this could be, say, a double LAN intake, or maybe if you've got really fast internet, you could have this as a WAN import. But it's possible that maybe that's overkill for the firewall. Maybe I'll use one for the actual LAN input, and then maybe I could use the other port for all of my virtual machines. They'd all then get to share a 10 gig connection. Obviously I've got 4 slots in here that I can use, so I could actually shape up, maybe I could have 2 of these. I think there is also a quad port version as well, but that's a bit more pricey. And last but not least, if I wanted some really fast storage, I could get something like this. This is an NVMe adapter, so I could basically get 4 M.2 NVMe drives into here and then plug that into the ×16 slot. Obviously, if I put this in, I wouldn't be able to put the discrete GPU in, or I might have to get some sort of adapter to maybe take that down to a ×8, but I don't have any experience in having done that previously, albeit I suspect it should work because it's quite a low bandwidth card. So hopefully from some of these peripherals and devices, you can see how the concept of an all-in-one becomes a possibility. So you can mix up these devices and basically build out the box that you're building to whatever requirements you need. If you need more networking, stick an extra network card. If you wanted extra fast storage, maybe stick another one of these cards in. And hey, maybe you wanted 2 discrete GPUs and you could put 1 to each virtual machine. So for building out this and having a bit of fun, and also kind of probably making it more relevant for you guys at home, this obviously comes with a SAS in there already, so a HBA for me to basically take advantage of all these slots. But I'm actually going to install another one just to show you kind of what it would look like and how that would work. I'm going to put the discrete GPU in as well, and I'll probably put in an extra 10 gig NIC. That would give me 1 extra slot which I could use for something else in the future. So after a bit of playing, this is what I settled on. I put in the GPU, I put in a NIC, and I also put in the SAS controller just so I can demonstrate it being passed through to various virtual machines, chiefly TrueNAS in this instance. Actually, the DGPU did take up one of the slot spaces, so again, you do need to think about slot layout in your motherboard. You might have things with space constraints, etc., that basically render one of those slots unusable. You might have to use a ribbon cable or something. But now this is set up, let's get into it. And so now with all of that put together, I've installed Proxmox. You can find a video on how to do that on my channel if you don't know. And I've basically followed again all of the existing videos that are on my channel to set up this mock-up Homelab. Now I'm not going to go into extensive detail on each of these. We'll have a quick look through some of the configuration settings, i.e. the hardware associated with each CT and VM, but this is pretty much what I said I would do. So I've got a CT here just for Pi-hole DNS. That would be a backup. Traditionally, I would set up Pi-hole within my Docker setup, or in fact, at the moment, I've got a Kubernetes cluster. This would just act as sort of a separate backup. I've then got OpenSense, which is the actual firewall itself. If we have a look at the hardware here, there's nothing really too special other than I've just created these 2 network devices here, and that's taking advantage of both a 10 gig and a 1 gig. I could obviously swap that out depending on what my internet connection is. If we actually go back to the device itself, so the HL15, so if we have a look on the actual networking tab here on the HL15 itself, you can see those network devices here. So effectively, I've labeled these 10 gig trunks here. So these ENO, so ENO 1 and 2, those are the corresponding 10 gig ports that are on the device itself. They're actually part of the motherboard. And then anything with the ENS is the 1 gig card that I put in. I actually ended up putting a quad 1 port in just because I've run out of SFP plus ports. So here you can see what I've done is I've basically created this firewall LAN. That's going to take up a 10 gig port. So effectively anything going into the firewall will all share a nice 10 gig connection. That should speed things up. And then for the WAN, I've just used one of those 1 gig ports. I would actually need to improve this to a 2.5 gig at least because I've got 2 gig internet, but 1 gig's probably going to be fine for most people. I've also then created just a basic VM trunk 1 gig again using another one of those quad ports, and I use that for the CT container because that should be more than enough just to run Pi-hole as a DNS. So if we go back to OpenSense here, you can see I've got that LAN and the respective WAN port. There's nothing too fancy about setting up OpenSense. And again, I've got a video on this if you want to go and check that out, how to install this. I've then put in Windows 11. Again, I'm just mocking up a demo Homelab. And here you can see that that's actually going to be sharing the 10 gig connection. For the Docker VM, given it plenty of RAM, and I've also put that on the 10 gig NIC as well, so that basically all of the services I'm going to run on here can run at 10 gig speeds. Lastly, I've got TrueNAS, and this is where we start to see some pass-through. So on this one, again, I've given it the 10 gig NIC, but here you can start to see really the first key thing. So this PCIe device here, this 19, if we actually go to the add and then we do some PCI pass-through, we can see on this list that actually number 19 is the HBA that was in there. I'm not sure if it's going to show because I've already allocated it, probably not. But you can see things like the dedicated GPU down here. So basically what would happen here is any devices now I've got attached to the HBA. So if I've got some hard drives attached to that, those would go through in a hardware form to TrueNAS, which is what it expects. It wants direct access to the drives. If, for example, on here you just clicked add and then you did a hard disk, that's not actually exposing the drive fully to TrueNAS, so things like trim, etc. won't actually work. You do need to pass through the raw drive. Similarly, if we go to Docker, here you can see that I've passed through this device here. So if we actually go and edit that, we should be able to have a look at here and find out that yeah, we've passed through here the ARC A380. I could also pass through the audio controller of the GPU if I wanted to. I've got videos on pass-through as well before where I've passed through dedicated GPUs, etc. So do go and check that out if you want to see that. I could technically as well, I could pass through these NICs as well. So I could actually go to the PCIe device and then do a raw pass-through of the actual card itself. But I've often found that there's no need to do that, and because I like to have, so I could pass through one of these for example, or the X722s, but I like to leave them as virtual devices, A, because I don't see any real performance overhead, and secondly, because you've basically created virtual NICs, it's much easier to migrate these in the future. If you pin them to hardware, you can still migrate, etc., but it might start breaking things, especially when it expects certain sort of hardware IDs, etc., hard-coded MAC addresses, etc. It does work, but there's a little bit more involved. So I like to keep it basically virtual and emulated. It makes the whole process a lot easier. So thanks for watching, everybody. Hopefully that's given you some food for thought around building an all-in-one. I am keen to take this a step further, and I am considering actually migrating all of my services, i.e. retiring my existing MSO1 cluster and putting it onto this device. I'm still torn as to whether I want to do that, but I do think there's some definite savings, especially around sort of space, cost, my time as well, all those sorts of things. I think if I wasn't doing this channel, I probably would have an all-in-one. I like to have the cluster obviously for testing, and it makes some interesting content. Plus, I am naturally inquisitive and I do use it for a lot of learning. There's a ton of stuff I've learned by having my own cluster set up. So again, obviously, Homelabs are for whatever you want to use them for, and you can change those at a whim. So that's definitely something I might do in the future, so watch out for that. Anyway, do let me know in the comments if you run an all-in-one, what are some of the challenges, how you've overcome them, what your experiences are, etc. Really keen to hear about that. Anyway, if you've liked this video, please give it a thumbs up, hit that subscribe. I'll see you in the next one. Take care, everybody.